Linear and nonlinear sequences. We have met linear sequences like the nth term being equal to 2n take away 3, which gives rise to a table of values like the following. So if we have n is 1, 2, 3, 4, 5, and 6, so that's the first term, second term, third term, fourth term, fifth term, and sixth term. When we substitute u1, so we're substituting 1 into un to give u1, then we've got 2 times 1 take away 3. So we're substituting 1 in for n on the right hand side as well. So that's going to give us 2 take away 3, which is negative 1. Then substitute n equals 2, and we'll find that u2 is 2 times 2 take away 3. So that gives me 1. Then when we substitute 3 in, we'll find the answer is 3. Substituting 4, 8 take away 3 is 5. Substitute 5, we get 7. Substitute 6, we get 9. Note that each time that the term number increases by 1, the member of the sequence goes up by 2. So if the term number goes up by 1 here, the sequence goes up by 2. So I've made a note of that here. Every time n increases by 1, un increases by 2. Another linear sequence would be that the nth term is 100 take away 5n. That would give rise to a table of values like this. So we've got 1, 2, 3, 4, 5, 6, and u1 here would be 100 take away 5 times 1, which is 100 take away 5, which is 95. And these are going to go down in 5s. So 95, 90, 85, 80, 75, 70, and every time n increases by 1, the term of the sequence goes down by 5. So we've noted that here. Every time n increases by 1, un decreases by 5. This is always the case for linear sequences. Increasing n by 1 will always produce the same change in un. In the first case, un went up by 2. In the second case, un went down by 5. If we graph these sequences, we end up with a straight line graph, hence the term linear. Note, these sequences are also known as arithmetic sequences. So here we have the graph of un is equal to 2n take away 3. So we've plotted the points from the table of values, and note how they lie in a straight line. We are now going to look at nonlinear sequences, where a change of 1 in n will not always produce the same change in un. For example, if we have un is equal to 2 to the power n, let's do a table of values for that. So n is 1, 2, 3, 4, 5, 6. So u1 would be equal to 2 to the power 1, substituting 1 in for n, and that's 2. And then u2 will be 2 squared, which is 4. 2 cubed is 8, 2 to the power 4 is 16, then we get 32 and 64. And that would give rise to a graph like the one shown below. And note how the points are not in a straight line. So this is a non-linear sequence. Obviously, there are lots of types of nonlinear sequences, but we are going to concentrate on geometric sequences, like the one above. This is an example of a geometric sequence. Quadratic sequences, and Fibonacci and Fibonacci-like sequences.